Yes, very clear.
Okay, nice. Hi everyone. Thanks a lot for coming to my talk. My name is Jiaxin. So I'm wrapping up from Michigan, and I'm also the core developer of Potato. It's an open source annotation system. So today I'll be talking about scaling up social research with efficient data annotation. I'm very excited to talk about this topic. It's actually my first time to. So I have been working on data labeling for a really long time, and each of my research project involves data annotation. But it's actually my first time to really talk about all of the heuristic, all the empirical knowledge we have built upon this road. So I hope this can be helpful for many of you. So if you have any questions during the talk, feel free to jump in. And there will also be two QA sessions. One is like after the first chapter, and another is at the end of the talk. So you can also hold your question until those two question answering sessions. Okay, let's get started. So we know that in digital society, there are a lot of unstructured data. For example, tweets. I'm pretty sure that most of us have studied tweets a lot because it's very available, well, at least a few years ago. We have been studying short videos like TikTok. There are a lot of news articles. So all of these are unstructured data that social science research have been relying on. And we have been trying to ask a lot of interesting research questions surrounding these unstructured data. For example, do left-leaning users hold more positive attitudes towards the government, right? That's a political science research question. Does the usage of swearing words in short videos improve engagement, right? So that's potentially a linguistic or a potentially like a marketing question or a communication question that many people care about. Third question is, did the media portrayal of AI change in the past 30 years? Right, this is also something that maybe STS scholars or maybe like journalism scholars will be curious about. So to answer all of these questions, we need to analyze the unstructured data at a very large scale. And the first step is trying to extract those structured signals from these unstructured data. For example, in the first one, we need to extract sentiment. In the second one, we need to extract swearing words. In the third one, we need to extract like the media framing of AI, right? So, and a common step in this process is called data annotation. It's like we need to, given a tweet or given a short video or given a news article, we need to annotate the occurrence of sentiment or swearing words or the framing pattern. And in a typical social science research pipeline that involves coding or involves data annotation, usually we start from the research question, like the three research questions I just introduced. And then we have the raw data, like the raw tweet data or the raw New York Times news article data. And then we conduct some manual coding to identify those signals we want to analyze. And finally, based on these signals, we can draw the final conclusion. So this is like a pretty standard social science research pipeline. However, the manual coding in the traditional social science research has many limitations. For example, it is very hard to scale. Like the largest qualitative coding project I have seen is a few thousand. It's like I can roughly say the range is from 100 to 10,000. It's really hard to scale this up with all the manual labors. And the second limitation is really hard to reuse. So even some researchers, they will like open source their like qualitative coding notebook, but manual coding is always needed for new data. You can't reuse the labor. The third issue is hard to replicate. It's very hard to replicate all the results from existing qualitative coding, because if you have like a different set of annotators, and you might see different results, even for the same data. So there are like all these manual coding limitations. So, however, in like for modern computational social science research, like a key pattern or like a key phenomenon of like CSS research is like we're relying on very large scale data sets. For example, on Reddit, there are 1 million posts every day. On Twitter, we have like 500 million tweets per day. This is like several years ago. So there are even more tweets nowadays. And even for like digital humanity project, like let's say you want to analyze the Project Gutenberg, there are like over 60,000 books there. So you can't rely on human labor to conduct all the manual codings. So like NLP researchers and many textual analysis researchers have been trying to propose a new methodology, basically. So based on the manual coding, we can actually train a natural language processing model or other machine learning model that allow us to automatically conduct large-scale data analysis. And then we can analyze unlimited amount of unstructured data and use that data to draw the final conclusion. So this becomes a new pipeline of computational social science research. So a key part in this talk, as well as in this kind of like NLP or machine learning for social research pipeline, is data annotation. Because like data annotation is a key for us to build a reliable like AI model for us to conduct all the automatic analysis. However, data annotation is actually very difficult to do in many practices. So in this talk, I'll be talking about how we can actually efficiently collect high quality annotations for your data. But the first thing I still want to discuss is why do we still need data annotation in the large language model era? I know like you probably have tried to use ChatGPT to do a lot of qualitative coding or maybe data labeling in many settings. But here I'd like to point out three dimensions. The first is evaluation. So even when you're when you're relying on LLM to do the larger scale analysis, you always need some data to evaluate large language models' performance on your task, because that like the large language model's performance on your specific task, it really depends on how you frame your task, how you design your prompt, and your specific task. So there are a lot of variations. The second is the performance. So large language models, they perform good on many tasks, but they still perform poorly on many social tasks, especially in zero-shot setting. So we do have like sometimes people have a lot of trust in these models, but in reality, based on some of our recent studies, we actually found that for many, like for example, emotion analysis, intimacy analysis, empathy, for many type of like classification tasks, like domain specifically fine-tuned small-scale language models are still better than large language models, because the large language models are designed for general purposes, not for specific tasks. So you can imagine like a human being who is capable of answering many questions, who has really good language skills, but you still need to train the annotator. You still need to train them for several rounds to like have them have a good annotation quality for your own data. So it's a similar it's a similar pattern for large language models to work on like specific tasks. And the third dimension, and it is actually very important, is efficiency. But basically, large language models, they're good on many tasks, but they're very slow and expensive. So let's say you want to analyze 500 million tweets, right? Which is a very, I mean, for CSS research, you have seen those kind of study a lot. So you can't have use ChatGPT to analyze 500 million tweets. Those will be super slow and super expensive. But if you, let's say you want to analyze sentiment, if you have a domain-specific fine-tuned like model, it can be like the task can be done in several hours, right? So based on these three reasons, we still need data annotation, we still need domain-specific language models or NLP or machine learning models for us to conduct large-scale social analysis. And another important thing I'd like to mention is data annotation might be more important than you expected. So many of people who haven't worked on data annotation before will think data annotation is just, I mean, you just label some data. But it sometimes is actually not as simple as just label some data. And usually we have wrong expectation about the time like allocation. For example, before I work on any serious data annotation project or any kind of CSS research involving data annotation, my impression is, okay, maybe I'll spend 25% of time on designing the research question, 25% time on data, 25% on annotation, and 25% on analysis and drawing the conclusions. But after working on so many CSS research involving data annotation, I realized the reality is sometimes you only spend 10% on research question, 25% on data, 5% on analysis, but you spend 60% of your time on annotation because there are so many noises, there are so many unexpected things to happen in the annotation, because that's the part you rely on multiple human beings to finish your task. So this is actually the reality that many machine learning researchers, many social science researchers who work on data annotation have been observing. So I guess like it is very important to bear this in mind, that data annotation is very important and it can be very time consuming. So you must take it very seriously. So today, this talk will be introducing a list of heuristic or empirical knowledge that I have personally built through years of research in data annotation, but basically how to effectively collect annotations for your data. So I'd like to introduce 5 major dimensions. The first is what to annotate. So basically, different type of like modalities, like different annotation schemas. And the second is who to annotate, like who should be your annotators, where to recruit them, like what's the pros and cons of different type of annotators. The third is quality check. It's like we always need to ensure the quality of our annotations, and how can we design the annotation task to make sure that the quality is good. And after we collect the data, how can we actually make sure that the data is good to go? The first is post-processing. So when we have the data, we always need some post-processing for machine learning to build machine learning models. And the final is annotation loop, like what's the overall procedure to build a successful data annotation project. So these will be the 5 major dimensions I'd like to cover in this talk about data labeling. So let's start from what to annotate. So what to annotate here, the most important thing is what is the annotation target, right? Let's say you have text, you have image, you have videos. A lot of like new research involves annotating image or short videos, right? So image and any image or any short videos or longer videos can be your annotation target. And for text, there are more variations. For example, you can analyze the text at sentence level or at paragraph level. For example, this is a tweet. I mean, if it's a short tweet, it would just be 1 sentence. If like a longer tweet, it can be like a paragraph. Or you can annotate maybe a paragraph or a few sentences within a news article. So you really need to decide like that. What's the smallest unit you want to show to your annotators? And you can always annotate your data at the discourse or the article level. You can show them the full article and ask them to, let's say, annotate the frames of this news article. There can be article level annotations. Or there can be more interesting cases where you don't want to annotate a single instance. You want the annotators to actually annotate pairs. For example, like given these 2 tweets, which one is more funny, right? Which one is funnier? I mean, that's a very pretty common NLP annotation task. Or you can also present like a tuple, right? For example, maybe 4 tweets and ask them to rate which is the funniest tweets presented here. So there are different levels of annotations that you actually need to choose. You need to decide when you have a new annotation task. And the second, and which is also a very important thing to notice for like what to annotate, is data sampling. Because the fact is we can only annotate a small subset of the data, right? Because usually for example, we're seeing 500 million tweets, and we can only annotate maybe 1,500 of them, and then we need to build a machine learning model like based on the annotations, and the model should be good enough to analyze the whole 500 million tweets, right? So how you sample, but we know that we can only annotate a small subset, like only a small sample. So how you sample the data will affect the model's performance, will affect the final model's bias, and will also affect like the final analysis and conclusion you draw from the large scale analysis. So it is very important to notice what data you're actually sending out for sampling. I definitely see many people who work on data annotation just do a random sampling and send it out for annotation. But in the end, they notice that, okay, like 80% of the data have the same label. It's pretty common. Because the reality is normal distribution hardly exists in the real world. For example, one example is like uncertainty expressions. So one of my previous project is trying to analyze uncertain cues in scientific findings, right? For example, the Arctic sea level might be increasing by 0.6 meters in the next year, right? So might is an uncertain cue, and we are trying to analyze the uncertain expressions in scientific writing. And so at the beginning, we simply draw a random sample, and then we found that only 10% of the sentences contain a single like uncertain cues. So if we directly draw a random sample, in the end, like out of like, let's say, like, for example, if we annotate 1,000 instances, like only 100 of them will be containing the uncertain queues, and 95 of them will be may or might, right? So that's something you probably don't want to do, because like you can't build a good model, like a model that is able to analyze all the variations of uncertainty in your large scale data set. So it is very important for you to actually balance your sampling process. Another example is sentiment. We all know that human language have positivity bias, which is suggesting that actually, so if you draw a random sample, you will see more positive sentences or positive words than negative comments or negative words. So even for sentiment, such a like pretty common task, you still need to make sure that your data sampling is balanced. So that being said, like during the data sampling process, we usually want to balance the data we annotate. And here's another example is, for example, we want to annotate the misinformation in news articles, which is a pretty typical CSS task. And for example, the data source one is all the New York Times news articles, right? So in this case, what you will be seeing is, we know like New York Times is a decent news agency, and they do pretty good fact checking. So if you're trying to annotate misinformation in New York Times news articles, probably see, okay, only maybe 1% or even fewer are actually misinformation, right? So it'd be really tough to find those misinformation cases. So in the end, you will get a super unbalanced data set, like probably only 1% are positive labels. But another example is all the articles from an Onion News website. We know like Onion News, they always publish fake news, right? Those news are designed for fun, not for serious purposes. So if you draw a sample from there, you probably see, okay, everything is misinformation. And in that case, it's very hard for you to get negative labels. So maybe in this case, you actually need to balance these two sources and mix your data and then send it out for annotation, right? So that's just one potential option you need to consider. But what's important here is, given any data sources, the first and the most important thing you need to think about is make sure that to notice, okay, what are the potential biases here in this data set, and how that relate to the annotation target and the label I want to get. And then think about how can I get a potentially balanced set sent out for annotations. And another important thing to notice is we not only want to balance the potential label, for example, in this case, it's misinformation in the like in news articles, but also we want to balance other common dimensions. For example, still in this case, we want to balance the topic, right? We know that like in a natural sample, the topic are also like not normally distributed. You might see, for example, in New York Times, the dominant category of news article is potentially politics. That's just my guess. And if you just do a random sample, in the end, you will get most of your data annotated in the politics domain. If that's what you want, I mean, that's a good thing. But if you are trying to get a balanced data set annotated and build a machine learning model that is able to handle different topics, right, that will be a bad thing. Another is an outlet. We know that in news articles, like some outlets, some good outlets, they have very high quality data. Some bad outlets, they have low quality data. So you probably also want to balance your outlet in this case. And the time of publishing also matters a lot, right? Consider an article published 30 years ago and an article published today, right? There can be many language differences or topical differences. So all of these dimensions is something you potentially want to think about when you're trying to draw the data sample for your annotation. And so there's a short, like a quick takeaway of this section for data sampling is, so there's basically no perfect data sampling strategy. It's always a deliberation process. It's really depending on the specific data you're using, depending on the specific annotation task you want to have annotators work on. But the more time you spend here, like thinking about all the potential biases, thinking about the potential dimensions that will affect your labels, affect like the distribution of labels throughout the annotation. The more time you spend here, the fewer problems you will see in later stages. So what is really bad is you spend all the money, because we all know that we only have like limited budget for annotation. Sometimes it's $1,000, right? And if you're annotating your own data, you have limited time frame to get this task done. what's bad is you spend all the money and time on this task, but in the end, you found that the data is not usable, is not useful to train a model, and then you don't have the resource. So that is something we're trying to avoid through a really good and well-calibrated data sampling process. So it is very important to always check the data samples and to really seed your data samples, because we're only annotating a small subset. So you can always put your data in a Google Sheet and just like look through them, make sure there are no noises, there are no bad cases, making sure if there's any systematic biases, make sure that you can always do another like bucket sampling to adjust it. So data sampling is a very important step to make sure that your data annotation is successful. The third piece of like what to annotate is what labels do you want to get. So there are a lot of common annotation schemas or tasks. For example, Likert scale it's a pretty commonly used. You can choose 7-point Likert scale, 5-point Likert scale. It really depends on the specific task or the nuances of the annotations you want to get out of this task. And you probably have seen like multiple select, like it can be like a very classic classification task for sentiment or for pizza toppings. Another pretty common NLP task is span annotation. It's like, let's say, sometimes you want to like in a news article, you want to identify those sentences that are mentioning specific entities, right? That's a span annotation task. You're like annotating the start and the end of a sequence. Another common type is text. So basic, for example, like summarization, where sometimes you want like the general feedback from your annotators, like text box is also a pretty common annotation schema used in research. So these are the common annotation schema. And there are also many ways to frame your question. For example, for sentiment analysis, you can use a Likert scale ranging from very negative to very positive as the annotation schema, but you can also use a radio button. You can also consider it as a single choice classification task, for example, happy, angry, chill, or many other types. You can also use a comparison, for example, which tweet seems happier, right? So that basically is a pairwise comparison task. And finally, you can also generate the subjective ratings for each tweet, like how happy this tweet seems to be. So there are like many ways to frame your question to the annotators. There are many ways to frame your like annotation task with different type of annotation schemas. So these are all the things that you can potentially think about when you're trying to design your annotation task. It is very important to think about the potential difficulty, the potential biases when you're making all of these choices. So this is the first part about what to annotate. So we have discussed like what are the annotation targets, what are the potential annotation schema you can use for your annotation task. And regarding like which schema should I use, sometimes you probably just want to check the literature because there are already like a lot of discussions. For example, for emotion analysis, there are a lot of classic psychological theory around, okay, what are the 5 common type of emotion that human actually observe, right? So you can follow the literature, or a lot of times you can actually create your own schema. And I know like actually for many type of NLP or for many type of like social science or computational social science research, like figuring out what is analytical framework is actually one of the most important theoretical contribution for such a type of research. So you can rely on the literature, but you can also develop your own annotation schema. And then you also need to think about the nature of your task. Like when human beings are processing information, do people have internal skills or measures for the construct? For example, for sentiment analysis, you can use 5-point Likert scale, or you can also use a 7-point Likert scale. So which one do you believe is the most suitable for your current task? Which one do you believe that human actually have internal skills or measures for this construct? So that's a question you probably want to think about. And you can also actually trying to run several pilot studies with different design to figure out, okay, which one might be might be a better one. So yeah, these are all the things I'd like to cover regarding what to annotate. Oh wait, why is this? Oh, sorry. There's another last note is, so basically, you also want to think about the complexity of your task. because like having more nuanced schema can be helpful sometimes, right? Because like we're getting more information from the annotation. But it can also increase the cognitive cost for your annotators, and which might actually lead to lower inter-annotator agreement because people naturally get tired. And you can also think about potential human biases, and human always have biases in this kind of subjective annotation tasks. And the one common type is called skill bias, that when you give people a skill, let's say like 5-point Likert skill, people have different internal skills. So sometimes comparison tasks are more reliable than Likert ratings. For example, like the example I mentioned, you can actually converge like sentiment or emotion ratings into a pairwise comparison task, which is way easier for your annotators to work on. So these are all the things you can potentially think about when really design your annotation scheme. For example, this is a case. Basically, where here we can see consider the sentiment analysis task as a backward scaling task. Backward scaling is a task where you have like a list of instances, and you have the annotator choose the most, let's say, like most positive and the most negative sentiment. And then in the end, after some post-processing, you can actually convert these, like originally it's a rating, it's like a Likert skill rating task. You can actually convert it into a comparison task, which is way easier for annotators to work on. So there are a lot of like design choices that you can think about when designing your annotation schema. Okay. The second piece is regarding who to annotate it. Cause like a lot of times, who is your annotator is very important. And there are two common type of annotators. The first is in-house annotators. I mean, they can be RAs, they can be friends, or is like yourself as a researcher, like annotate a lot of data. Other folks you have to annotate. And you can recruit domain experts. So in the end, it's very easy to do quality control. So a lot of times we see that in-house annotations are leading to a better, like a higher quality. But the cons is most of the time it is very slow, because if you're only relying on one or two or several annotators, it is very hard for them to finish everything in a short period of time. It is very hard to scale because it's very difficult for you to have like more annotators, and so it's hard to scale to like a really larger set of annotations. It's hard to recruit a diverse set of annotators because, like, for example, for some tasks we want to have diverse, especially for subjective tasks, we want to have a diverse pool of annotators to make sure that we're actually getting the representative annotations. For example, for offensiveness or hate speech annotations. But if you're relying on in-house annotators, it is very hard for you to have like a representative sample of annotators, right? So that's another cons of the in-house annotators. Yeah. And another commonly used like annotators is crowd workers. So there are many platforms that provide services for you to easily recruit crowd workers. The first is MTurk. So it's called, like, the full name is Amazon Mechanical Turk. And MTurk has been used for many years. But you shouldn't be using this platform. I mean, this video won't be uploaded. So yeah, so basically is you shouldn't be using MTurk at all in your own research because it's that platform. This is based on many recent research, based on many experiences from my collaborators and my own research. There are other better platforms. For example, Prolific. Prolific is like traditionally is a platform used for survey research. So they actually have pretty good pre-screening, and the annotators are super responsive. So we have been working with Prolific for a long time, and the platform is really good. Another common platform is called Upwork. So Upwork is like less for data annotation, but sometimes if you want domain expert annotators, for example, you need to recruit 4 journalists to work on your task. It's really tough to recruit these type of people from Prolific, but you can actually directly reach out to folks on Upwork to recruit expert annotators. And there are many other new platforms coming up, and you can also check other online. So the pros of having crowd workers is it's very easy to scale. So it's basically, it's only a matter of money if you want to have like 100 annotator or 1,000 annotator or 10,000 annotators, right? As long as you have the money, there's no other cost to basically scale up your annotation task. It is very fast. So even you want a really large scale data set to be annotated, it can be done within several hours with such an annotation power. It's very easy to recruit a diverse pool of annotators, and many new crowdsourcing platforms are offering like pre-screening, for example, Prolific. They also offer like representative sample based on sex, age, and ethnicity. It's becoming more easier for you to recruit a diverse pool of annotators to really estimate the group-based differences. But the cons is it is very difficult to have training sessions. You basically so I have tried to design several training sessions, but it's really hard to do because usually the annotators can only focus on your task for maybe 20 minutes max, or maybe 30 minutes. If you have a long training session, which means that they have less time to really work on your annotation task, which is something we're trying to avoid. So in the end, it is very difficult to have training sessions. So my suggestion is that if you believe your task requires specific domain expertise, if it requires training your annotators, probably like CrowdWalkers is not the best case. Another concept like using CrowdWalkers is very noisy. It's really hard to do quality control because like you don't really know like who's your annotator, and they can be very diverse. So there can be a lot of noisy. They can be like working on your task while working on other tasks. So there can be a lot of noises. So it's very important how you pre-screen your annotators, which specific platform you are using. Yep. So just like a quick summary of like who should be my annotators. There can be a lot of factors to consider here. For example, the task difficulty. Does my task require specific domain expertise? Let's say you have two tasks. One is mathematical reasoning. Another is sentiment analysis. So probably mathematical reasoning is something you want to have like in-house domain experts because they actually require specific knowledge, and you can't actually rely on the lay public to work on your task. But for sentiment analysis, everyone can read and can perceive the sentiment. And actually, sometimes if you want to analyze the subjectivity in sentiment perception, you actually need to recruit CrowdWalkers to have a really diverse pool to understand the like individual or demographic differences. And yeah, like I just mentioned, another dimension to consider here is like subjectivity. It would be better to recruit a more diverse set of annotators when your task is subjective. There can be many factors, like for example, age, gender, sex, education, experience with maybe like technology or something. So it really depends on your specific task. Yeah. For example, for offensiveness rating is another like subjective task. You probably want to have a very diverse pool of annotators. But for reading comprehension is like less subjective. So it's okay for you to just recruit like whatever annotators, like whoever is currently available. So you really need to think about like the subjectivity of your task. And another question is like, how much should I pay the annotators? The typical rate is like 10 to 15 US dollar per hour. That's the standard rate to pay the CrowdWalkers, regardless of like who they really are. I know like some annotators, they come from India, they have like there's lower hour rate in the local market, but since they are on a global platform, like $10 to $15 is like typically the reasonable range of payment. And however, in reality, like annotation tasks are usually paid based on the specific tasks. It's not based on the like how much time each annotator spend on your task, right? Because we know that okay, if it's like a 5 minutes task and someone spends 30 minutes on it, so it's the issue of the annotator, not your task. You shouldn't be paying them 30 minutes because they spend 30 minutes because it's possible that they got distracted and they work on something else, right? So a typical procedure here is like you try to finish the task by yourself and count the time, and then you calculate the task-specific rate based on the hour rate and the task length. You run several pilot studies on crowdsourcing platforms and observe the median finishing time, and then you adjust the rate in your final annotation. So it's really you first try it out, and then you piloting a bit, and then finally you can decide the final annotation, the rate for your annotation task. Okay, so these are like who to annotate your, like who should be recruited to annotate your data. The third part I like to cover is quality check. Quality is the most important thing in your annotation, because we need to make sure that we're having like high quality annotations, and this will going to be something that the reviewer will care a lot about, especially like inter-annotator agreement. So how the first is like how to check the quality of my annotation. So there are a lot of ways to check it. For example, the first is behavioral traces. There are many like systems allow you to track how much time the annotator spend on your task, how much time they spend on individual instances. Another important behavioral trace is whether there are missing annotations. Sometimes annotators, if they are working on something too fast, they will miss annotation. So these behavioral traces can be good indicators for, okay, maybe some annotators, they only spend 1 minute for a task that is supposed to be finished in 10 minutes, right? So there's definitely something wrong with this annotator. So probably you should drop the annotation for the too fast annotators. Sometimes it can be a good thing if an annotator is too slow, because maybe they're just like really responsible and they spend too much time on this task. So it's really hard to tell whether a slow annotator is good or bad, but it's relatively easier to tell that if an annotator is being too fast, maybe, yeah, they're just like doing some random clicking. Another important like quality checker is attention check. So you can always insert a lot of attention check in your, it's kind of like traditional survey. You can also insert a lot of attention check questions in your like typical annotation flow. And whether the annotation are able to answer several simple attention check test question correctly can be a very important marker to show that whether the annotators are actually good or bad. You can also insert some like reverse questions or some golden questions. There are multiple ways to do the attention check. I won't go into details here, but there are a lot of important or like a relevant literature discussing this, like in the survey methodology literature. Another way to understand the data quality is you can actually use some NLP package to calculate the annotator competence. So if you use a package, it's called MACE. So basically, you'll be able to analyze the competence of each annotator, and they will give you a score from like 0 to 1. The higher means the annotator is more competent, and the lower means the annotator is potentially doing more random annotation. And this can be like another way to check the quality of annotators. And the last and the most important measure of data quality is inter-annotator agreement. So basically, inter-annotator agreement is basically trying to analyze whether several annotators who work on the same instances, whether they agree with each other. If you see that an instance is basically agreed by all the annotators, even in a cross-sourcing setting, so it basically means that, okay, everyone agrees, so this data is really reliable. But if you see that everyone disagrees, so potentially it can be true disagreement, right? Especially for some subjective tasks. But if it's like for, let's say, for mathematical reason, for what's like a result of 1 + 1, right? Like someone answer 2, someone answer 3, someone answer 1, right? There's definitely something wrong with the data annotation quality. And one commonly used inter-annotator agreement calculation here, especially in the crowdsourcing setting, is Krippendorff's alpha. I know many people probably have known about like Cohen's kappa. So, but like Krippendorff's alpha actually allow you to like analyze the inter-annotator agreement even when some data are missing, which is pretty suitable for crowdsourcing setting, because in crowdsourcing setting, you probably like not all annotators are annotating all the instances. So Krippendorff's alpha has been really commonly used, and if you submit an NLP paper like and with data annotation work, and reviewers would definitely ask about this metric. But sometimes for the subjective annotation tasks, like inter-annotator agreement is not the golden standard. Like I have seen like very low inter-annotator agreements for annotation, but you can still train reliable like machine learning model on it. But you really need to use all of the other quality checkers like attention check, annotator competence, behavioral traces to really justify that your data is actually having a low annotator agreement because of its true subjectiveness instead of like the low quality annotators. But overall, these are all the potential design or potential metrics you can think about to ensure that the quality of your annotations are good. So there are a lot of like design choices that can actually help you to attain this goal. For example, the most important thing is choose the right pool of annotators. And the second most important thing is for this is platform. Like I mentioned, don't use Amazon Mechanical Turk. Because it's really hard for you to get a good annotation out of like Mechanical Turk. And another way you can do is like pre-screening, because like for example, for a lot of the tasks that require domain specialized knowledge, you probably want to have people who have like relevant background. For example, I've been working on scientific data a lot, and sometimes we want to have people who with a computer science background to work on computer science articles. We want to have people who have a chemistry background to work on chemistry articles. It's very important to align your task with the expertise of your annotators. The second most important rule is redundancy. So we know that there can be a lot of noises, especially in the crowdsourcing setting. So it's very important to have more annotations per instance if you have enough budgets. Usually we recommend at least 3 for objective tasks like mathematical reasoning, so that you can actually adjudicate based on the disagreements. And for subjective tasks, usually we want to have like more than 5 annotations per instance, so that we can actually analyze the source of the subjectivity and do a better aggregation. So make sure that your the final aggregated scores are more representative. And third is like it's very important to include attention check questions. But if you believe that you indeed choose the right pool of annotators, it's actually okay to remove the attention check questions. But for reviewing perspectives, it will be really good to have an attention check question because you have like another metric to show to the reviewer that, okay, my data is actually good because all the annotators passed the attention check. Yep. So another dimension we need to think about is refine your task design through pilot testing. So pilot testing is very important because these are the where you can actually identify the potential mistakes or issues in your annotation at a very early stage. For example, did I choose the right schema? Maybe you shouldn't be using a classification task. You should be using a Likert scale. Maybe the task is too difficult. Sometimes if the task is too difficult, it's really hard to get a really high inter-annotator agreement. Maybe it's too complex. Maybe it requires specialized expertise. Maybe it's too long, right? Because like people can naturally lose their patience when they are working on something for over 30 minutes. So all of these design choices are the things you need to think about. And you can always get feedback through pilot testing. So pilot testing is really an important way for you to receive feedback, to observe all the important signals earlier before you spend all your money on the final annotations. Another very important thing to notice here, it's being increasingly important, is collect the background information of your annotators, because we know that there can be a lot of factors affecting the user's rating behavior. For example, we have seen for many subjective NLP tasks, certain type of annotators, they tend to give higher ratings or lower ratings. So it's very important to collect the background information of your annotators so that you can potentially analyze the biases caused by the background of your annotators. Okay, so yeah, so these are all the quality check things we need to consider when you're designing your annotation task. So after you make sure that your data is in good quality, you can do a lot of post-processing. For example, the first thing is remove low quality annotators, right? If you know annotators doing random annotation, just drop their annotations. You can use Maze to calculate the competence score. Another important post-processing is label aggregation. For example, for classification tasks, you can use Maze to aggregate multiple labels. For Likert skills, you can average the rating. It is commonly used, but you can also use other ways to generate the final labels. And you can also check the distribution of the labels to see, this is very important to do in the pilot testing to make sure that you're actually getting the desired distribution of labels, right? Sometimes maybe if your data sampling is done wrong, and you will get a very skewed distribution of the labels, which is something you don't want. So in the pilot testing, you are able to identify this problem, and then you can redo your data sampling. And then you can also do some initial statistical analysis. So you have your initial data, you can start to generate the plot, generate the analysis to see if there's any early pattern for the research questions you want to test. So these are all the things you can potentially do during the post-processing phase. Okay, so the four step, these four are the major things we need to consider during designing an annotation task. And then I'm going to introduce the overall pipeline of a successful annotation loop. So usually you start from a task design. You have your basic annotation setup. You know what data to annotate. You have the target. You have the schema. And then what you need to do is pilot testing. It's pilot testing is very important. And then after pilot testing, you need to do quality check, because quality check can tell you that whether your task is designed in a good way. And then you receive all the fixed signals from quality check. You receive all the feedback from your pilot annotators, and then you can refine your task design and run another pilot testing. So you at least need to run 2 rounds of pilot testing before you launch your final annotation project. The first pilot testing is to just receive feedback. Each annotation project is badly designed at the very beginning, but you can definitely improve that a lot through several rounds of pilot testing. So I have seen some of my previous annotation tasks. They went through 4 rounds of pilot testing just to make sure that everything is correct. Because once the money is spent, it's gone. So after you make sure that your task design is actually good and you have the whole pipeline ready, you can launch your full annotation and spend all your money. But still, it's good to spend your money in batches. For example, if you want 2,000 instances annotated, you can run them in batches, let's say 500. So basically, you get them down in 4 batches, and you can still observe all the differences or do quality check. Basically, larger scale pilot testing until all the annotations are collected. And then you can do quality check, and you can do the post-processing to generate the data you need. So this is basically like a mature annotation pipeline that you should consider for any of your annotation tasks. And some final notes is data annotation is important and hard, so please treat it seriously. There are so many design choices that you need to make, and all of these factors going to affect your annotation quality. So it's very important. The second part is several good pilot tests can save you thousands of dollars. I've seen many people waste their money because they didn't do pilot testing. So it's very important to run pilot testing because it's cheap, right? If you're not sure about your design, run a pilot test and get feedback from your annotators. And always back up your data, because bad things can happen. Once your money is gone, it's gone. All you have is your data. So sometimes so I've been using GitHub to sync up annotations across different machines. You can actually use GitHub to keeping track of all the annotator history and all the data annotated. So it's actually a very useful way. So what you can do is you create a GitHub repo for your whole project, and you have a directory for your annotation task, and then you save all the instances, raw data, annotations there, and periodically sync up with the remote GitHub repository. So this is a very good practice for you to follow for any of the annotation tasks. Okay, so yeah, so these are all the things I'd like to cover about efficiently collect annotation for your data. So in the second part, I'd like to talk about some very specific use cases, how basically you can use Potato, which is our open source annotation system. You can use this system to actually actively manage the quality of your data, manage all the data annotations. So it's basically a system that can help you to do all the existing things in an easy way. But before that, I'd like to take questions, maybe 2 questions. Yeah, feel free to jump in.
Okay, thank you, Jiaxin. So, anyone has any question? Okay. Okay. Hi, Dr. Jiaxin, can you hear me?
Yep.
Okay, so thanks for your talk, and it's really helpful and practical. So I have a specific question regarding the part you say the we should consider the complexity of tasks when we try to do the annotation because it aligns with my current difficulty in one of my ongoing research. So it's like my collaborator, they want to do a project about the miscitation of research papers. So like a lot of we just miscitate a lot of papers in our writing, and we want to see what is the proportion of this phenomenon happens, and requires us to annotate the miscitation and the correct citation from a very large range of papers. But the task I feel is quite complex because you need to first read the original sentence and the citations and the cited papers, and like we need to view and see which part it contains. So it's very like I think it's a lot complex procedure. And I think my first question is, do you have any suggestion for this process, like any automated tools or anything we need to consider during this process?
Yeah, yeah, I think it's a very interesting task and also very difficult. So I can imagine there are several things you probably need to consider. Like one is data sampling, because maybe I don't know, like maybe the true like miscitation rate is like, let's say it's 5%. If it's like 5%, which means that if you do a random sample, yeah, and you can only get like 5 out of 100 like citation cases. So how you can actually find those cases more frequently, maybe active learning is a way to do it, right? So that's something you can potentially consider. Another thing is like, I know like it's very difficult for like another thing is like who to be the annotators, because obviously if you're annotating specific domain, like only like domain experts can tell whether it is miscitation or not. So you probably want to think about, do you need PhD students to work on this task, or any person with like a, let's say, a bachelor degree in relevant domain can work on this, because that will affect how you recruit your annotators. On Prolific, you can recruit a lot of people with specific degrees. Like you can, for example, if you're trying to like analyze medical research, you can actually recruit like graduate students with a medical degree. So that's something you can do on Prolific. But if your task requires like higher expertise, maybe you probably want in-house annotators. The third piece I'd like to mention is like interface design, because obviously it's a really hard task. You need to read the original article. Like so you have two articles, right? One is the original article, another one's like the article who cited the paper, and another is the like original article. And you also need to help them to navigate through maybe the abstract or something. Yeah, because and then in that case, I think thinking about how you want to design the task. So later we'll be introducing our open source annotation system. You can potentially use the system to prototype a bit with your annotation setup. Because like this system is very flexible. It allow you to embed like HTMLs or even like a PDF reader. So it might be actually a potential solution for your case. But yeah, so we have a documentation, and so I will introduce some basic setups about the system, and maybe we can follow up later on the specific use case.
Oh, okay, thank you. And can I ask one small individual question? Like, if you recruit the in-house annotators, you feel it's necessary to like pay them because they are mostly your friends, but you require them to
yeah, I mean, it really depends on how much annotations you want. I mean, yeah, I have seen free labor a lot because I mean, yeah. I mean, yeah, it's really basically if they are okay with it, then just do it. Yeah. Yeah, there's yeah, I mean, sometimes like people will give authorship to data annotators if the annotation is really important. That's a potential way. Another way is you just thank them in the acknowledgement section.
Yeah. Okay, thanks. Okay, so you please.
Okay, thank you, Dr. Peng. I'm Xue Ye. I'm very enjoy your sharing, and I want to know more about data sampling. You mentioned that it's hard to find normal distribution in the real world. I want to learn more about your statement. I want to know what's the main difference between data set from computational approach and data set from traditional survey experiment, and how will this difference influence a final data analysis and findings? I want to learn more about this part.
Could you specify a bit regarding like what you mentioned about survey research and the larger scale?
Because you mentioned that in data sampling in computational communication, it's hard to find some normal distribution, right? Because are certain expressions and segment. I want to know the difference. What's the main difference between the data set and the data set from survey or experiment, especially how will influence the final findings?
I see. I think it's a totally different setting from survey research, because for survey is like what do you want to get out of it is like people's opinion, or like most of the time. The analyzing target is people. But for like large scale data like larger scale analysis, the target here is unstructured data. It can be tweets or it can be news articles. So the research questions can be very different here. So I'm not sure if these two are actually comparable. But for the data distribution, I think it's a problem like more common in like larger scale analysis. Like in a smaller scale analysis, let's say you have 50 interviews, right? It's like a qualitative study, you have 50 interviews. Yeah, it's very easy to read through everything, and you can identify all the potential biases in this data. And a lot of times, like those biases are something you probably want to discuss in your paper, right? Because that's that's a point of qualitative research. But when you're working on, let's say, 50,000 interview scripts, you cannot like read them through right in a like reasonable amount of time. So you need to rely on these models or automatic tools. Like these automatic tools are built upon the label data. And if your label data have biases, let's say, for example, if this tools, like, let's say you want to see, like, analyze the sentiment, and somehow your data is annotated in a biased way, and the model is capturing, let's say, green, right? If they all see the word green, and they always considered it as positive, right? But we know like green it should be a neutral one, but it can be a potential bias in your annotation or in the data sampling. And the model learned about this pattern, and it automatically label each sentence with green in it as positive, right? So yeah, this will going to affect your final conclusion. You might see null result because of this bias. But a lot of cases is if this is done in a wrong way, you don't even know where's the bias. Like you don't even know what's leading to a like null result. So which is really bad. So that's why it's very important to think about all the potential factors when you're doing data labeling and run several pilot testing to make sure that to check the distribution of your labels, make sure that you're annotating the desired samples.
Thank you.
Okay, so this is the final part of our question, and Jiaxin, you can continue with your second part.
Okay, sounds good. I guess the second part will be more fun because I'll be like showing some real applications. So basically, I'll be giving an overview of Potato. It's an open source annotation system you can use. I'll be like introduce how you can launch your first example annotation task, which is very easy to do. The third, I guess it will be a take-home like won't be an exam, maybe a take-home task or something you can try out later after this session. So basically, Potato is an open source annotation system developed by folks from Michigan. UIUC and Berkeley. So basically the design like philosophy here is make sure it's like easy to deploy, like it can improve the annotator's productivity. You can do better quality control with it, and it's like highly accessible. I like to show some like examples for each of this. So first is like easy configuration. So you don't need any coding background to use this tool. So basically it's like a configuration file driven. So I'm sure you probably, everyone here has some like coding experiences. So you don't need to code, but you just need to fill out some like structural forms like this. Like what is the annotation schema you want to use? Is it like multiple select? What is annotation task? What are the labels here? Just like what I have introduced in the first part. It's just like we have make this into a software where you just type this here and the software will automatically generate the like interface for the annotators to work on. So basically if you write this, it will get you this like interface. And we provide a lot of templates. Like templates is all the potential ways you can annotate your data, like Likert skills, text box, password scaling. You can even annotate image or span. So yeah, like you don't need to write any code. You just change like the schema name in your configuration file. And we support internal annotations and cross-sourcing annotations. So basically you can, we provide like seamless integration with Prolific, and you can easily scale your annotation task on Prolific. And also there are some like simple but nice feature to have that can help to improve the quality, like the productivity of the annotators. For example, you don't need to like use your mouse every time. Like they can basically use keyboard to directly type in the result here, which is very useful. You can, for a lot of like complicated tasks, we know like for social science research, sometimes we have really, for example, analyzing the framing of news. Each framing can have a very specific definition. It can be long, and you can't display them in the first interface, but you can like insert those as label tooltips. So basically, once the annotator's mouse is hovered over it, like you basically will be showing the description of this label. So basically, allowing them to easily observe the definition and to work on your task more efficiently. The third piece is conditional highlighting. Sometimes we have a really complicated annotation schema. For example, this is trying to annotate the immigration framing. It's like there are 30, I think 26 or 30 like categories. It's really complicated. And you can actually display some conditional highlighting to help the annotators to navigate through these labels. We also have active learning deployed in it. You can use it. Another like cool dimension we have is like better quality control. So like many of the existing annotation systems don't allow you to insert survey questions, but here with our system, you can insert pre and post screening questions. Like you can insert consent questions. You can also insert like demographic questions to better understand your annotators after they have worked on your annotation task, which is very helpful for like especially for subjective tasks. And we have built-in attention task questions, so it's also like configurable. You can easily like configure like attention task questions like in the configuration file. And so once this is done, you can easily analyze like the attention task question results. We also allow you to insert qualification tasks before annotation, but I have seen people rarely using this because yeah, like just 5 questions is potentially not enough. What's more important is finding the right annotators. And like we're free for everyone. It's fully open source. So if you like it, you can give us a star here. And what's another cool part about our project is like it's easy sharing and replicating annotation setup. So you probably have seen these examples from like existing studies, and you can actually directly get their annotation setup to use them in your research. So you don't need to reinvent the whole wheels, but you can follow the best practices from existing research and modify the configuration file and directly use that for your annotation task. This is a really nice feature to have, and we have over 20 annotation like example projects now, so you can easily try them out for your own case. So yeah, this is just a very brief overview of how what you can do with Potato. And I'd like to show how you can actually launch your first example annotation task because it's going to be super fun and very, very easy to do. So I'm going to switch to another screen. Okay, can you see my desktop now? There should be a browser and a terminal and the folder?
Yeah, consistent.
Okay, nice. Okay. Is the terminal font large enough for you to see? Okay. How about now? Is it better?
Yeah.
Yes.
Okay, sounds good. So basically, I'm not sure how many of you are actually experienced with using terminal, but it's very easy to use. So in Windows, it's called command line 2. On Mac, it's called terminal. So basically, terminal. You can like create a new terminal. And then here, basically, you go into your project folder. And the first thing is like you need to install like Potato through like PYPI is pip install. You can just like follow the so we have a very nice documentation here. Let me put it here. So basically you just like run pip install potato annotation. Yeah, and it will like automatically install everything for you locally. And then we have a super cool command line too. You can check all the existing like example projects. Basically, it's like potato list all like here. And then you'll be able to see, okay, these are all the example project you can actually use. So like in the documentation, you can see all the example project like on this website. For example, offensiveness rating. Let's say you want to annotate offensiveness. Like you can run potato get offensiveness. So then like this annotation project will be fetched on your computer. Let's do it right now. So you run potato get offensiveness. Yes, you see like a successfully fetched offensiveness. And now you see that in this folder, you actually see there's a offensiveness project, which is exactly the same annotation setup as here. And in this project, you'll be seeing like several subfolders, like configuration is a configuration file that you want to check. Data file is a raw like annotation, raw data you want to annotate. Survey flow is a list of like survey questions you want to include in your annotation setup. And the template is providing you an easy way to actually modify the layout of your task. So this is a basic setup of your project folder. And the configuration file is a major thing you need to add it for your annotation task. You can see you basically, yeah, like you define the port, what's the annotation task name, where you want to save your data, where is your input data file, and like how you define like the location of your survey flow pages, how you want to assign the annotation task, and like what's the annotation schema you want to use. Like here is a Likert and can see there is a comment on Reddit. How offensive do you think it is? So basically this is like everything you need to define a single annotation task. And I'm going to show you how you can, what you can get through this annotation task. So basically here you can type potato start offensiveness -p. -p means like defining the port and 8000. So here we're using the 8000 port on your computer. And then it will launch the website. And if you go to localhost, yeah, so basically here, this is already a task set up for Prolific. So that's why we are seeing this screen like Prolific PID. So let me type it here. So, so basically, if you go to this link, this will be the annotation site that launched just by running potato start offensiveness. So you can see, okay, this is actually the annotation task you can display to your annotators. First, you can show the introduction, like what's the procedure here, move forward, instructions on how you want to work on this task. Like you have like all these consent questions, and then move forward. And here comes like the real annotation phase. Basically, you show them the instances. Here is a comment from Reddit, and they can like choose like their answer to basically label here. And each annotator can work on 50 instances. You can predefine this in the configuration file. And then you click on this, click on this, click on this. And after the task, we will be basically showing them a survey question about their background. So this is like a basic annotation setup. It's very easy to use. You see, like you don't need to code and like anything. You just need to like type potato get offensiveness, and then you run potato start offensiveness, just as simple as what's written here. It's very easy to use if you're adopting like an existing annotation task. There are many other like example project available. For example, for question answering, this is like a span annotation. For text rewriting is like, let's say you want to rewrite this email to be more polite. You can analyze dialogue, you can analyze sentiment. So yeah, so there are a lot of like example project available here, and you can fetch them like at all the existing annotation setup and easily launch them. And if you want to modify those annotation setups into your own specific annotation case, what you need to do is just open this configuration file and then modify it, right? Let's say here for this offensiveness rating task, now I don't want to annotate the offensiveness. I want to annotate maybe sentiment, right? So you can basically change the word sentiment here. Sentiment. And then, okay, if you, let's say we still want to use a Likert scale, you can say maybe this is like very negative. And then the max label is very positive. Okay, so now you have like modified the annotation task. Although we do need to delete the annotation output here, but, and then you can directly start the offensiveness task with this new setting. And we start to keep this part. Yep, and then it's like modified. So basically it's showing like how, like, I mean, sentiment, like what's the sentiment using it is, it's running from very negative to very positive. But basically, like if you want to modify the existing template into your own annotation setup, you just need to add this configuration file. Yeah, that's it. And we have a like very detailed documentation website. So basically you can go here to check like all the use cases, how you want to like prepare your data, what data type we support. So it's, yeah, like it's a very detailed documentation that you can adopt. Yep, that's it. So basically now it's like here, like it's an example how you can launch your first example annotation task. So yeah, we probably don't have the time for the third piece, but you can consider it as like a small practice if you're interested. It's basically you fetch the example project offensiveness and you try to modify it to like to achieve the following goals. For example, you want to change it to each instances should be annotated by 5 annotators. Each annotator annotates 40 instances and like add an annotation schema named the sentiment and launch it at port 8000. Yeah, so I guess it's just like a small like take home task you can do if you're interested in using this system. And if you have any questions, you can always email me. I'm pretty responsible for anything related to Potato. I'll try to be responsible to other requests too, but yeah. You can also submit like GitHub issue, which also helps the community to better keeping track of all the potential issues. But yeah, that's it. And yeah, so if you are interested in this project, you can go to this link and we have a nice documentation. But yeah, so that's basically everything I'd like to cover today. I'm happy to take any questions.